Welcome to today's Explainer. Take a quick look around you right now. The buildings you see, the cars out on the street, massive pipelines, even the tiny little electronics inside the device you're using right this second, all of it relies on one absolute powerhouse of a force to hold our modern world together, and that's welding. In this Explainer, we're going to totally unpack the engineering and the science behind modern welding techniques. It's this brilliant, almost magical mix of raw power, intense heat, and honestly some pretty mind-bending physics. Let's dive right in.
But okay, before we get into the really wild, specific engineering solutions, we kind of need to nail down exactly what welding is at its core. Basically, welding is a process where two or more metals, or even thermoplastics, are permanently joined together. How do we pull that off? Well, by applying intense heat, intense pressure, or sometimes a combination of both. You know, it's really not just about gluing things together. It is fundamentally fusing materials at a molecular level so they literally act as a single unified piece of material.
So here's our roadmap for today. We'll start with everyday solutions, then scale things up to heavy industry, blast right into the high-tech frontier, and finally, wrap it all up by talking about choosing the right tool.
All right, Section 1, Everyday Solutions. We're looking at arc and gas welding.
Right off the bat, there's a huge direct contrast between the two most common methods out there. On one side, we've got arc welding. Now, this method relies heavily on an electric current to create a literal spark, an electric arc, that generates enough heat to instantly melt the metal. Boom, done. On the other side, though, we have gas welding. This uses a mixture of fuel gas and oxygen to create a flame. And notice the key difference here. Gas welding requires absolutely zero electricity, none at all, which makes it completely 100% portable.
Now, arc welding is actually kind of an umbrella term. It includes shielded metal arc welding for your standard manual jobs, gas metal arc welding, which you probably know as MIG, gas tungsten arc welding, known as TIG, and flux cord. But the absolutely crucial takeaway here is that this method is the most common for a very good reason. It's incredibly cheap, it's relatively easy to learn, and it is the absolute go-to solution for heavy construction, repairing structural work, and building massive heavy machines.
But hey, what happens when you're, miles and miles away from a power grid? That's exactly where gas welding steps in, specifically oxyacetylene welding. It is basically the portable superhero of the industrial world. Because it doesn't need a power outlet, you can take it literally anywhere. It's the ideal, highly effective solution when you need to fix pipelines out in the field, or when you're working with super thin metals where an electric arc might just totally burn right through and ruin the whole shebang. Moving on to Section 2, Heavy Industry, specifically resistance and thermit welding.
So how exactly do we tackle massive, repetitive industrial jobs? Think mass-producing cars or laying down heavy sheet metal. The answer for large-scale manufacturing is resistance welding. Notice the heat source here. It's actually a combination of electric current and physical pressure. By clamping metal sheets together and forcing a current through them, the natural resistance of the metal itself generates this intense heat, melting them together at a specific spot or along a seam. It is incredibly fast. And a massive advantage for assembly lines like car body manufacturing is that it requires absolutely no extra fill material. You literally just press, zap, and move right on to the next one.
Next up is a method that relies on some seriously brilliant chemistry, thermit welding. Forget electricity and forget pressurized gas for a second. Thermit welding relies on a highly intense chemical reaction to generate its heat, and it creates an incredibly strong joint on exceptionally heavy parts. If you've ever found yourself wondering how they seamlessly connect heavy railway tracks out in the middle of absolutely nowhere without hauling giant power generators around, well, this is it. It's heavy-duty, relies on zero external power, and gets the absolute toughest jobs done.
All right, Section 3, the high-tech frontier. We are talking solid-state and beam welding.
I want you to think about this for a quick second. We've pretty much established that welding is all about melting metals to fuse them, right? But can you weld two metals together without actually melting them at all? It sounds completely counterintuitive, doesn't it? Like there's no way that works.
Well, the answer is actually yes. Welcome to solid-state welding. This process joins metals without ever reaching their melting point. Instead, it uses intense friction or even high-frequency ultrasonic waves to bond the metals together at a molecular level. Types like friction, ultrasonic, and diffusion welding are incredibly effective. And why is that? Because when you don't melt the metal, you get absolutely zero melting defects. None. This guarantees exceptionally strong joints, which is exactly why this specific method is trusted in the aerospace industry and for ultra-high precision work.
And speaking of high precision, let's take a look at laser beam welding.
This method uses a highly concentrated laser beam to melt the metal with absolute pinpoint accuracy. I mean, when you're dealing with microscopic electronics or incredibly sensitive medical equipment, you really can't afford a messy weld. Lasers provide these ultra-clean, high-precision joints that traditional methods simply cannot match. It's a real game changer.
Rounding out our high-tech frontier, we have electron beam and plasma arc welding. Think of these as the ultimate precision tools. Electron beam welding fires high-speed electrons in a strict vacuum environment, and this allows for incredibly deep penetration right into the metal, making it absolutely vital for the aerospace and nuclear industries where failure is, well, simply not an option. Then we have plasma arc welding, which gives operators even more accuracy and ultimate control compared to standard TIG welding. It is the perfect choice for flawlessly welding high-quality stainless steel.
Finally, Section 4. Choosing the right tool. The grand comparison.
This breakdown perfectly summarizes our entire journey today. The heat source entirely dictates the use case. So we've got arc welding, using an electric arc for general, heavy-duty work. Gas welding uses a portable gas flame, which is perfect for thin metals and field work. Resistance welding combines electricity and pressure for lightning-fast sheet metal assembly. Laser welding brings that concentrated beam for precision, high-tech work. And thermite utilizes chemical reactions to fuse massive railway tracks. See? Everything has its specific engineered place.
From the simple gas torch repairing a pipe under your street, all the way to the solid-state waves building the next generation of spacecraft, these techniques are literally the fundamental bonds of modern engineering. As materials continue to evolve and our engineering goals reach further into the stars, which of these welding techniques do you think will shape our future? Thanks for joining me in this explainer today. Keep wondering, keep learning, and I will see you next time.